one presentation. We are glad to present to you Cat Assist, an AR powered assistant that helps you to use Caterpillar's high utility vehicles with ease. First things first, the research stage. But what is it that we're trying to help the users with? We tried to come up with some ideas about what problems can be solved, and we decided we had a look into different possibilities and we came up with a couple of problems. First of all, we wanted to evaluate if an augmented dashboard can be used to help people users use the Caterpillar's UTVs. We wanted to see if there's a single AR implementation that can actually accommodate every different type of control that we can find from a variety of vehicles that CAD produces and do this with a consistency. Finally, we wanted to see if there's an augmented dashboard implementation that can help new users to learn how to use the CAD machines in an easier manner. Training new users is a costly and an important issue for all the companies, and that's what we try to address using our CAD Assist. So first things first, we decided to get into the mind of the user and create an experience map of how a user would feel and see when he enters the vehicle. So we start off with the novice operator getting inside the vehicle. What's the potential thought? That he's gonna get to understand a lot of different things and there's little confusion. He starts to turn on the vehicle and cannot find the ignition switch. He has to find the ignition switch and turn on the vehicle in a proper manner. Then the user chooses to perform the function. If the vehicle is at the correct position, it performs the operation. If not, they try to move the vehicle to the required spot and get the thing done. What are the potential thoughts at this stage? Why isn't the lever working? How do I move this vehicle to some other point? These are all the questions that a user might have while you operating the utility vehicles. We decide to think a little deeper on the choose node point for our experience map, so we expand it and look at it in a deeper sense. What does the novice operator think? He looks at the panel, he tries to figure out what button does what kind of work. Maybe he selects the incorrect button and does some erroneous operation. The user thinks that he's wasting time or he might have to do something to avoid getting fired, and he goes back to fixing the problem and then trying to select the correct button. During all these experiences, there are a tremendous number of emotions going through him. He might be angry with the inability to use the vehicle, or he might be overwhelmed with the ease of using the vehicle. All these emotions bring together the entire experience that these users can have while operating a CAD machine.
The goal of the generate step was that each of the team members individually come up with various crazy ideas that could be streamlined, discussed in the future, and merged together. So, what the team went about doing was that we individually made the crazy eights. These crazy eights were pretty crazy in the extent that we were thinking about image recognition, radar, a see through body, a terrain sensor, and even we were envisioning our AR application to be similar to Jarvis from Iron Man. But what happened after this was that we chose one of these ideas and we created a story about it. So these stories revolved around various features like gesture recognition, voice control, a heads up display saying what's happening right now, where you need to turn, and all that. So, with this as a base, we joined together in our choose phase. In this phase, we voted on all of these stories that we had built, and then these votes were essentially personal votes, and we talked about why we voted for this and why we didn't vote for this. And in the end, we see that the voice recognition got 5 votes, the gesture recognition got 5 votes, the heads up display got 4 votes, and so on. But the one common thing in all of these stories was that we were aiming at making the life of the user easier by making this AR application as a user manual, which could be interacted with and all that. So in this step, we decided that we were going to merge the voice recognition feature, the gesture recognition feature, and this would allow us to give more interaction capabilities to our augmented reality application that would serve as the user manual and help them in certain situations. So based on this, we came up with a story that whenever a problem occurs, the operator puts on the AR goggles and activates the voice recognition. He says, "Engine stopped working. What do I do right now?" So the AR gets activated, and what happens is you can see various information like engine information, temperature settings, fuel status, battery status, and all that. And then the AR application shows him exactly what he has to do, where he has to press, and all that so that he can get going again.
So let's move to prototype section. Here you will see demo videos of interaction between the operator and cat assist, that is the AR assistant.
Hey Cat Assist. Activate learning mode. Sure. Here you go. Show more info for wiper. Sure. Hey Cat Assist. Deactivate.
So as you saw in the video, when we activate the learning mode, basic information of the control is augmented, and upon further query, more information of a specific control is shown. Next is the demo video of hand gesture.
Hey Cat Assist. What does this control do? It controls the bucket arm. Show more info. Sure.
So this demo was fairly simple, where operator points to a specific control and asks for more information. But hand gestures have lot of applications like augmented menu where the user can scroll up and down. Next, we will see the video of asking specific instructions to complete a specific task to cat assist.
Hey Cat Assist. How to start the engine. Press this red brake. Hold onto the brake and press this button. Good job. Engine should start now.
So other example of similar application could be an operator asking how to take reverse and cat assist giving the instructions accordingly. Now we move on to evaluate stage, which is the final stage. So we divided our evaluation part in two sections. Here are the results for the first part. We interviewed five participants who had varying driving experiences, and only one was familiar with the interiors of a utility task vehicle. First, we showed them the dashboards of CAT vehicles, the images of them, and then showed them the prototype videos. After that, we asked general questions of the usefulness of AR assistance and got very positive feedback. We also made them rate the features that you saw in the video on scale of 5, and we got pretty good results. As you can see, most of them have 4.5 out of 5. So second part was more about making the participants familiar with AR eyewear and giving them hands-on experience. So we rented an HoloLens and asked them to play a simple game that involved basic hand gestures and voice commands. Most of them, as you can see the results, most of them got comfortable within 10 minutes with the HoloLens. And when asked how easy was it to learn hand gestures, they rated it 3, 5 being very difficult. And then later we asked them how aware they were of the environment when they were wearing the eyewear, or were there any view restrictions, and the answer was minimum. Lastly, the participants were asked how comfortable would they feel while driving and doing the following things, like wearing an eyewear, interacting with voice commands, and interacting with hand gestures. As you can see, not many of the participants were comfortable using hand gestures while driving. So that were our results. Thank you.